Honors Algebra 2, Chapter 6, Part 3, Section 3. So we're going to, two parts. We're going to add, subtract, multiply, and divide functions first, and then we'll look at something else called compositions next. So if we're doing the operations with functions, it's really what we've been doing with polynomials. So we're going to find the sum, difference, product, and quotient is of functions. For sum and difference, all we're really doing here is just simplifying. The only thing that may be a little different is this notation. So f of x plus g of x is the same thing as f plus g of x. This notation means we're just taking two different functions and adding them together. So we're just adding like terms. So we use this notation, the function notation, to say what you're doing with the functions. So the difference would be f of x minus g of x, which is the same thing as f minus g of x. So you're saying what you're doing with the functions, and then you're stating what the independent variable is after it. This is still one polynomial here, or this is one expression here. This does not mean a multiplication. This means you take an f minus g of x is the expression. The product is f of x times g of x. It could also be written as f times g of x, and then quotient f of x divided by g of x is the same thing as f divided by g of x. Notice that we have to say that g of x cannot be 0 because we cannot have 0 in the denominator. We can't divide by 0. So this is more of just notation. We're going to be using the function notation to describe what's happening. So some examples here. So we have h of x here, and here's the expression for h of x. And we have g of x, and here's the expression for g of x. And then with the problem is saying find h of g of x, knowing that x is 10. So we can look at this problem two different ways. We can look at h plus g of x, which means the same thing as h of x plus g of x. So you're just taking and adding the two functions together. And so if we actually write down the two functions, h of x is 3x plus 3, and then we're going to take that function and we're going to add to it g of x, which is negative 4x plus 1. And then you just combine like terms, so you get negative x plus 4, that would be the result. But we're not really trying to find the function, we're trying to find it when x is 10. So then we can actually plug in 10. So now we can say that the h plus g of 10 is equal to negative 10 plus 4, which is negative 6. We could have found that same problem by, instead of adding the two functions together, we could have plugged in the h of 10 plus g of 10 and plugged x, or plugged 10 in for x in both functions. And if we show that, so we plug 10 in for h of x, you're going to get 33, and plus plug 10 in for g of x, you have negative 39, and you combine those, you get negative 6. So it's the same answer either way. So we tend to, a lot of students tend to like to plug in the numbers right away and then use that to find the operation. But I will have some problems, or we will be evaluating problems that don't have the x value. You have to leave it with your variable and just simplify. So in 5 here, again, we're plugging in 3 for the function, 3 into both functions for x. So, and then we're going to subtract them. So g of 3 minus h of 3. So plugging 3 in for g, and for g of x, you're going to do 2 times 3 minus 5, which is 1. And then we repeat that right here. We're going to subtract h of 3. So we're going to plug 3 into the second function. So 4 times 3 is 12, plus 5 is 17. And so if we subtract that, we have negative 16. This is the same kind of problem, g minus f of f. It can be written as g of x minus f of x. And then we do not know x here, so we have to use the function. So g of x is negative x squared minus 1 minus 2x minus f of x. Now be careful when we write this. We are subtracting all of f of x. So you have to show parentheses around this f of x. You have to include the parentheses here because this negative goes to both those terms. So this is going to be negative x squared minus 1 minus 2x minus x minus 5. So if I distribute the x, I no longer have the parentheses. Now I can combine like terms. So you get negative x squared minus 3x minus 6 is the final result. So be careful with your basic algebra. So multiply and divide. So this we have our two functions again, g of n and h of n, and then we're finding g times h of 1. So we can do g of 1 times h of 1. Again, we can plug 1 in for both of these, or we can find it with the function. And so you plugged 1 in for the first value. You're going to have the 1 squared plus 4 plus 2 times 1. That's the g function. And then we're multiplying it by h, which is going to be negative 3 times 1 plus 2. And so we have 1 plus 4 plus 2, or 7, times negative 3 plus 2, or negative 1. So we get negative 7. We can find that same answer by doing g times h, multiply them first, and then plug in 1. But it's probably even more complicated. For that one, you have to do n squared plus 4 plus 2n, and then you have to multiply that by negative 3n plus 2. So you have to do all the distributing and then plug 1 in. It's easier to plug 1 in right away than multiply the two results. For the next one, we actually are doing it for x, so we cannot plug a number in. We actually have to do it with the functions. And here we're dividing f divided by g of x. We want to do f of x divided by g of x. F of x is 3x minus 1. G of x is x squared minus x. And then we can look to see if we can reduce anything here. And we'll talk more about that in future chapters about reducing. If there's anything you can see right away, then that's fine. But here's the result. We could state that x here cannot equal what value. So to find that, you set your denominator equal to 0 and you solve that. So this is good knowledge of quadratics. I factor out x here, I get this. So I say x equals 0, x equals 1. Those two values will make our denominator 0. So x actually cannot equal 0 or 1. If x is one of those two values, you plug it in for those two x's, you get 0 for the denominator. We cannot divide by 0. So you really should be including both of those. Whenever you're dividing by the function or have a denominator with x, you should be stating the domain, what it cannot be. So x cannot be those two values. That's the first part. Part B is looking at something called compositions. So compositions is when we take a value like f of x, and instead of putting x in, you're actually going to replace x with an entire function. So we can write that as f of g of x. And so you're taking the portion that was your x here, and you're replacing it with all of another function g of x. And so that's called a composition function. And so the formal way, g of f of x is equal to g of f of x. So this dot symbol is really the composition. For the sake of our class, I'm probably going to keep it here so you can see what's happening. To evaluate, you substitute all of f of x in for the x in g of x. So you're replacing the x with an entire function. And then we can repeat the other way around. So f of g of x is just the other way around. So you're going to put g of x in for all the x's in f of x. So example here. So we're given g of n is equal to this function. H of n is equal to this function. I want to find g of h of n. So what it's saying is we want to take the h of n function and put it in place of the x in g of x. So g of x, we're going to replace that x with h of n. So if I write out the g function, the g function is 2n plus 3. That's the g function. But instead of writing n, we're not going to write n. We want to replace it with h of n. h of n goes in place of n. Well, h of n is the entire function n minus 1. So when I write this, g of h of n, we're going to write 2 times, instead of writing n, I'm going to replace it with all of h of n. So n minus 1 plus 3. So n minus 1 is h of n. And then you just simplify. So you have 2n minus 2 plus 3, or 2n plus 1. So I'll put more examples here. So we have g of n and f of n. We want to find g of f of 2. So we can look at this two different ways. We could take f of x and put it in place of g of x. So I could write it like this: g of f of x, find that first, and then plug 2 in for x. That's one way of doing it. So if I'm writing that, if I write my g function, and instead of writing n, actually it should be n instead of x, instead of writing n in this function, I'm going to replace it with whatever f is. So that I put in the f function. The f function goes in place right here. So it'd be the 2n squared plus 5, so it goes in place. And then you can evaluate that, and you get 6n squared plus 15 plus 2, or 17. So you can evaluate the composition, and then you can plug 2 in. This is one way of finding the value. So now you can plug 2 in for n. So you have 6 times 4 plus 17, or 24 plus 17, which is going to be 41. That's one way of doing the problem. The other way is actually g of f of 2. Finding f of 2 first. So taking and finding f of 2 is going to be 2 times 2 squared plus 5, or that's going to be 4, 8 of 13. And then taking that value and plugging it in for the x and g of x. So then g of x, 3 times n plus 2 is g, so then I plug in 13 in there. So that's going to be 39 plus 2, or 41. The same answer either way. In the second example, we need to actually do h of g of x. There's no number here, so you have to do the actual composition with the function. So the function h of x is equal to x squared minus 2. We have to replace the x with the g. We want to put g of x in place of x, and that's what h of g of x represents. So when I write the h of x, all of x is actually g, the 4x plus 1 squared minus 2. So I've taken out the x and the h. That x, we've taken out and we've replaced it with what g of x is. Now this one's a little more difficult to do, to simplify, because it's 4x plus 1 squared. So be careful with the square of the binomial, so you actually need to FOIL that. And you'll get 16x squared plus, and that's going to be 8x plus 1, and then minus 2. And then there's your final result. And then you could plug in different values for x if you had to. So a few more here. So for this one, g of h of a. So when I write the function g of a, which is 2 times a plus 2, and I replace the a value with the h. So that all goes in place of the other a value. So negative 2a minus 5. So I'm replacing a with the other function. Then I have to simplify, so I distribute, and then combine like terms, find the result. This one here, g of f of x, so I can write the function g of x, and instead of writing x, I'm going to leave that blank, and I'm going to replace that with the other function f of x. So f of x is going to go in place with the other x, and then simplify, so 2x squared plus 6x minus 2, and that's it. So we'll use we'll use compositions when we talk about inverses here in the coming days, the following day, and then later in math they keep popping up with compositions, some good application problems. So we'll call it good for the night, and we'll see you tomorrow.